Hello, and welcome to my video about systematic sampling, a type of random sampling that is distinct from simple random sampling, cluster sampling, and other forms of random sampling. I will get right to the chase of showing you how it works in Posit.Cloud and hopefully describe it in doing so at the same time. So I have my cool data set from my previous video about Alberta smoke plume data from wildfires in Canada. And so I'm going to import that. And as I do so, we will notice that it is a 233 observation data set of 43 variables. That is a fair amount of information. It could be advantageous for us to have a smaller chunk of this collection of observations, so fewer than 223 observed smoke plumes, but while retaining all of the information about each of the ones that we select at random in some fashion. How do we do that? Well, we take a systematic sample. So first, I will need to run some numbers to compute some values so that I can take a systematic sample. So what's our population size? Well, as I just said, see if I can type and talk at the same time. Jury is out. It is the number of observations in my data set, which is 233. So I'm going to make a variable called population size that here you can see has the value of 233. But if we want to ask the computer to tell us, there you go. We call population size by its name and receive our answer of 233. How big do I want my sample? Let's say I want 25 of the smoke plumes rather than the full 233 that are available. That's quite a bit of data, even though perhaps you've seen a bigger data set in your very own Posit.Cloud already. So here, well, I said I want a sample of size 25. I'll just request that number. And then when I ask for my number back, well, I'm pretty sure, and yep, it gave us the same number back. So if I want 25 things from my population of 233 things, if I pick a random starting point, how big of a step should I take so that I end up collecting a total of 25 things as I walk through the data set, which is how systematic sampling works? Well, we will call that the sampling interval. And it turns out that you can compute it by taking the population size over the sample size. And so another way of thinking about that is 233 divided by 25, which I'm running in the console here. And you'll see that that is 9.32, which is not a whole number. So I'm using the ceiling command here to round up to the nearest whole number. And let's see if that worked. Once we run it, it did. The rounded up value of 9.32 is 10, which is a value that I can take. So okay, so the idea is I want 25 things from my big data set. I want to get them by starting somewhere random and taking steps of size 10 and collecting the next thing that I see and repeating that process until I have 25 things. I guess I need a random starting point. So random start. Well, I'm going to choose a number between 1 and my sampling interval. And I only need one such number to find a starting point. And I forgot to ask for it to tell me down here in the console focusing your attention on the console, even though you can see in the environment what's happening, because something else will, the fruits of our labor will appear in the console once we're done. Is one place we can see them. Okay, so our random starting point is a number between 1 and 10, which is 3. Cool. So now I am going to make my list of steps. I will take all of every 10th observation, starting from the observation number 3, which will hopefully get me 25 of them as we go. Possible that it will result in a number similar to 25. Let's find out what happens. So I'm going to make a sequence of numbers from my random starting point to my population size by my sampling interval. And I think it will be easiest to show you what happens by running this. Oop, I have a typo and got an error message. And what do? We fix the typo and get on with our lives. So you can see this made something. What did it make? It made the following list of numbers: 3, 13, 23, 33, 43, 53, 63, to up to 223, 233. Is that 25 things? Well, I don't know. Let's see. Because now we have a list of indices. We have the ability to take a systematic sample. Let's do exactly that. So my systematic sample is my data set at those indices, and we run it. And one thing we could do is print our systematic sample and see what we have here, which will then show up in the console as follows. And we'll see, we have taken observation number 3, Trout Mountain, smoke plume. Observation number 12, TP Lake, smoke plume. Observation number 9, or number 82, excuse me, Ponton, smoke plume, with all of the associated variables. So if you want a better look at that, you can click on it in the environment up here and note that it is indeed 24 things. Well, actually, it's 22 things, and then 2 empty rows, but nonetheless, it is a sample that maybe because rows at the end of the data set are themselves empty. That is the case. So there were some empty rows. We caught them systematically. That's okay. But voila, a smaller sample that was random in some fashion. How so? Well, let's go again and illustrate. So I'm going to take my systematic sample. I'm going to fully clear my environment and then re-import my data set. Same one, same empty rows at the bottom. Well, not totally empty, as we saw. They had some kind of erroneous recordings. In any event, how many actual rows do we have? 222 real rows. I'm going to ignore that for now, although we could modify a couple things in here and only catch the real rows, which would be something that you might eventually want to do if you care about having your data as clean as possible. Think about what changes you could make to this that would invoke that we know more about our data set now, having looked at it. For example, the number of rows is 233, but if I just change this to the number 223, then I would only be looking at the real ones. But let's say I want a sample of size 14, and will this work? run. I have my, okay, so my population size 233, my sample size 14. My sampling interval is 233 divided by 14, round up to 17. My random start is 10 this time. My systematic sampling indices are 10, 27, 44, 61, 78, 95, and so on. Steps of size 17, starting at the randomly selected value 10, up through the end of our data set. And now we take the systematic sample. And if you want to print it, you can, but I'm just going to click right over here. And look at that, a sample of size 14 systematically. There you have it. Enjoy.